Today is Thursday, May 14th. We are going to be continuing our conversation about glaciers and running water. This is the worksheet we're going to be filling out. You'll have your Loom video attached here. We're going to watch the power of water erosion at deltas, and answer a couple of questions from those videos. Then we're going to watch a video on the Grand Canyon Formation, answer these questions. Then we're going to watch this YouTube video and answer these questions, and then answer these questions here about stalactites, stalagmites, and columns. Okay, so again, we're on day 2 of these notes. They're the same notes that have been filled out and shared with you the last couple of days, or I guess technically on Monday. This is one of the videos, what it should look like, the power of water erosion, and this is another example of water erosion in deltas. I am not going to leave both of these up because they're going to kind of make things a little slower on my laptop. But I am going to pull up our PowerPoint and continue to talk to you about what you need to know from that. And it looks like the computer's running a little slow, so I'm going to go back over here and pause. All right, so we are recording again. Sorry, guys. We are going to start off with running water, and I'm going to give us a little bit of details. These are the 2 videos I just showed you online. So a process of erosion and deposition, okay? As gravity pulls water down a slope, the water's potential energy changes to kinetic energy so they can do work. The water has the ability to pick up and move sediment, okay? When water is removed by the water feature, or when sediment is removed by the water feature, it's called erosion, and when water drops it off, it's called deposition, okay? Now, looking at this picture, okay, explore the course of a river. There's a waterfall or a rapid down here. It's a very steep slope. There is some serious fast erosion here where there could be very big boulders move because the water is moving so fast. The faster it moves, the bigger objects and the more it can carry because it's going like a freight train. It just has so much momentum. It's not going to stop until the hillside is less steep. Okay, as it becomes less steep, it will drop off the bigger rocks and sediment. It will start to slow down and meander, which are all these big curves that the water takes as it's going through. The waterfall also occurs in a very V-shaped valley because it's eroding at such a fast rate. It is moving a lot of rock very quickly, and it's going to whittle through it very fast. Okay, a tributary is a slow stream or river that is going from a different, less steep portion of the hillside. Okay, and it is going to deposit some sediment as it goes, and it will continue to connect into the other body of water and make its way out to the ocean. Okay, this river here has what's known as an oxbow lake. What's happening here, and there's another oxbow lake over here. You see they're like these little horseshoe shapes. As the river is meandering, water likes to take the path of least resistance. So at one point in time, the water curved all the way over here, and as it was curving, it dropped off more sediment on the inside of the curve and eroded away faster at the outside of the curve, and eventually cut itself off from the rest of the river. Okay, so we have these oxbow lakes where there's natural pooling of water that occurs. It used to be once a part of the river. If you guys have ever floated Indian Creek or the Boise River, there are parts where your tube gets stuck on the sediment, the inside curve of the bank, and then the outside curve is super, super deep because it's just getting hollowed and whittled away faster. A delta is another depositional feature of a river. As the river is moving, it's carrying sand and dirt and debris. As it gets out towards the ocean, it makes a fan shape. A delta is the Greek name for their letter of a triangle. And so a delta is a triangle shape formed at the mouth of a river where it slows down to meet the ocean. And this is where a lot of sediment is dropped off. Okay, the valley has now officially widened to a big triangle shape, and you can see some beaches off here over to the side. Okay, so V-shaped valley, this is river erosion. At one point in time, the river was moving super, super fast, and it whittled a very steep V shape. Here is some pictures or a video of the Grand Canyon that you're going to use to fill out your worksheet. Okay, so again, we are filling out this worksheet right here, okay, you should have answered erosion and deposition. Now we're watching a little video clip on the Grand Canyon, okay, and answering what are the erosional features of running water and explain what's happening on the Snake River, okay. So going back to our PowerPoint here, this is a example of a waterfall. Okay, if you guys have ever heard of Niagara Falls, this is beautiful. It's on my list of places to go. Never actually been, but it is breathtaking based on the photos. All right, so this gives you some floodplains. As you guys can see, there's a massive amount of water here, more water than can be absorbed by the ground, so it's considered a floodplain. A floodplain happens to bring more sediment to an area. As the river recedes, it drops out the sediment, creating terraces. You guys have ever been to Hawk Stadium? That is an example of what happened during a floodplain. So processes and features explained by erosion and deposition. So there are modes of transportation: meander formation, oxbow lakes, floodplain or stream terrace, and then sediment deposition. So if you guys look, there's different symbols for these that you'll be able to see. These are all some website links that are attached to our worksheet that you can go to and look through. This goes through a meander formation. So here's a river. It's taking the path of least resistance. As the river continues over time, there's lots of deposition, lots of sediment building up on the inside of the curve. The outside of the curve has lots of erosion. The water is moving faster. Eventually, it will create a turn that's so steep that the water wants to take a path of least resistance. And so it's going to cut off and create a different channel and an oxbow lake. Here's a video of how meanders can be explained. You need to take a second to watch this. A river curves, it meanders. The erosion and deposition takes place within the river channel. Erosion takes place on the inside or the outside of the meander. You tell me. And the deposition takes place on the inside or the outside of the meander. Based on the previous pictures here, erosion is occurring on the outside and deposition is occurring on the inside. Okay, they produce oxbow lakes, point bars, and cut banks. Okay, this is a meandering channel. You can see the water takes the path of least resistance. The insides of the curves are getting the deposition of sediments. Okay, at one point in time, the river curved this way. Then it took a path of least resistance. Eventually, this guy over here will take a path of least resistance and either go straight here or it'll go straight over here and create an oxbow lake here or an oxbow lake there. So where the river cuts out and whittles away to make a steeper curve, it's known as a cut bank. Okay, so a cut bank is the side that you like floating down the Boise River and it speeds up and like slingshots you out really fast. Whereas a point bar is where if you get your tube too close to it, you're gonna have to shimmy and shake to try to get over the top of it because that's where all the sediment's being deposited, dropped off. An alluvial fan is another delta shape. It's where it's the opening of the mouth of a river, and there is a bunch of sediment and debris being dropped off. You can literally see the piles of sand forming as the water is trying to take the path of least resistance. Here are some other alluvial fans. Alluvial fans typically happen at the base of a steep mountainside, so the valley is running water out towards an area and it's fanning out in all direction as the water literally comes to a stop or a halt and it slows down. Oh, sorry, went through a couple too quickly. Here's another example of an alluvial fan, just a giant sediment area being deposited. This is a river delta. Pretty sure this is at the base of the Mississippi. Yeah, it is. Okay, so Mississippi River Delta. The river is carrying lots of sediment and debris out. All the green areas are places you could like walk on with vegetation and stuff because there's so much rich nutrients in soil that the Mississippi River strips away from the United States and all the farming land as it travels down the middle of the US and deposits them as it reaches the ocean. This is another river delta created by deposition. You can see the piles of dirt forming as the water makes it to the ocean. All right, sinkholes. These are so cool. You guys are really gonna want to check these out. Watch these YouTube videos here. The features of both meanders. We saw this earlier. So caves, which would be part of similar to sinkhole features. Okay, they have stalactites, stalagmites, and columns. Okay, stalagmites and stalactites are amazing. There are these really, really cool features. Stalactites form from the top, and stalagmites form from the bottom in these pictures here. It's where water drips down and calcifies over hundreds or millions of years, um, and forms these shapes. All right, so again, you should have been able to go all the way through this. We are comparing and contrasting stalactites, stalagmites, and columns. If you have any questions on those, watch the videos attached. You should have everything you need. If you have questions or concerns, email me. I hope you guys have a great Thursday.